Good evening, Sampath.
Good evening, sir.
Good evening, everyone. Good evening, everyone. Am I audible?
Yes, sir. Good evening.
Okay. Okay. So in the last class, we done with bio, right?
Yes, sir.
Last class we did bio, and so today we'll be doing physics. You have 3 days science classes. So one day you will have physics, one day chemistry, and one day bio. भी फैन ऑन कर देना फैन ऑन करो Okay, so let's say we today will be doing the third law of motion, which we started in, I think, previous week. So third law of motion. Anyone remember the statement of the third law of motion?
Sir, every action has an equal and opposite reaction.
Very good. So according to the third law of motion, every action creates an equal and opposite reaction. So this is the third law which states that for every action, whatever action you create, action means a force. If you apply any amount of force, so you also get a reaction force, which is just equal and opposite in nature. Equal means the amount of force that you are applying, it will be the same as you applied. And the reaction force will be just opposite to it. So for every action, there is an equal and opposite reaction. Got it? We try to understand this with a number of activities. I tried out, I told you that yes, we can try it out with the number of activities. I think we I tried to explain you with a spring balance. So suppose here we have a we have a wall, and on this wall we attach a spring with the help of a hook. Suppose if you have a hook over here, and here we attach a spring balance. So let's say here we have a spring balance attached to this. And now we attach another spring balance on the other end. So on the other end here, We fix another spring balance like this. इसमें मैं कम कम कर कम कर देना. So suppose I start to pull this spring. Let this be spring 1 and this be the spring balance 2. So suppose I start pulling this. I start pulling the spring balance 2. Now I will observe that there is some displacement in the first spring. Also, there is an equal displacement in the second spring. So both the springs will show me the same amount of force. The amount of force of the spring 1 will be equal to the amount of force of spring 2. So what happened over here? I applied a force F. Then by the same force, I applied a force F on the spring 2. Then with the same force, spring 2 is pulling the spring 1. Okay. So with the same force, spring 2 is also pulling the spring 1. So when spring 2 starts pulling 1, as a result, spring 1 also starts pulling the spring 2. So that is why you have an extension in spring 2, because spring 1 is pulling the spring 2. Got it? So this proves that for every action, there is an equal and opposite reaction. Okay. We'll observe some with some other activities also, like if a person jumps out of a boat. So suppose we have a boat and someone starts jumping out of the boat. So what do we observe? Suppose here is the person and the person starts jumping towards this side. He jumps towards this side. So what action? This is the action. So what do we observe over here? Yes, what do we observe as per the reaction?
Sir, can you repeat?
So if ever tried to jump off a boat, so if a person jumps off a boat, so while jumping, he pushes the boat in the backward direction. Okay.
Yes,
So
sir.
he pushes the boat in the backward direction. Because of his push in the backward direction, he gets an opposite reaction and hence he is able to jump forward. Right. So we observe here that for the action he created, there is an equal and opposite reaction. He is obtaining the same amount of reaction, or he is obtaining the same amount of force with which he pushed the boat. Okay. So pushing the boat is the action and he is getting jumped out. That is a reaction. Why he can jump? It is because of the process of reaction. Also, if you observe the swimming process, how do we swim?
So we push the water backward so that we can go forward with our legs
While
and
swimming,
arms.
yes, what happens while swimming?
We push the water backward in the backward direction to move in the forward direction.
Yeah, we push the water in the backward direction. Here, we push the water in the backward direction with our hands. We push the water in the backward direction. Water is pushed backward, and hence we get a forward reaction. So the faster we push the water backward, the faster we go forward. Right. So while swimming, we are applying the law of action and reaction. Okay. I'll also show you some more things which are based on the action and reaction.
Sir, I have a doubt.
Yes, what is
Sir,
your doubt?
while we are in the water, why do we feel light? Means we
Yeah,
feel
when we are in the water, we feel light. That is because of the buoyant force or the upthrust exerted by the water. Water pushes you upward, and hence you feel lighter. Okay.
Okay, sir.
Uh, just a minute. I'm trying if I'm able to locate it. So that is how it happens. Hmm, just 1 minute. I'm trying to locate it. Otherwise, I will explain it without that also. Okay, I think that image is not available. You can search it out and see later on. Just I observed few small videos pertaining to it. Okay, I'll just explain you what happens over there. Suppose you take a toy, okay, and here I place a toy on this road. So, okay, a toy is placed over here. This is just your toy, and on this toy, I put a straw like this, and the straw is mounted with a balloon. So if you blow air from here, the balloon will swell up, right? And when you stop, okay, so when you blow air into this, so the balloon swells up, and when the balloon swells up, then what happens? If you start blowing, so the air from the balloon it comes out through the straw, and when air from the balloon comes out through the straw, then it pushes the toy in the forward direction. Okay.
Sir, but from where we are blowing it?
You hold the toy in your hand and blow from the straw only.
Okay, sir.
So,
So can we tell the diffusion occurs in that process because the air has higher concentration in the balloon, whereas the atmospheric pressure is less, and the
uh,
pressure in yes.
yeah, what happened? Pardon?
So can we tell diffusion happens because the atmospheric pressure inside the balloon is higher than the atmospheric pressure outside the balloon?
Yeah, it is because of the pressure only. It's because of the pressure. It is because of the pressure that the air is coming out, right? It's the pressure only, the region that the air is coming out. And when air is coming out, it's moving in the backward direction. And that is the region the toy is being pushed in the forward direction.
So can we tell diffusion occurs?
Diffusion.
Yes, sir.
Okay, where are you talking for division? Diffusion.
So in the above example of the balloon,
About?
the toy and the balloon, that
See, diffusion, where are you talking? When the air comes out of the straw, then you are talking
yes,
of
sir.
diffusion.
Yes, sir.
Yeah,
Because
so
there
of
is
course, yeah, of course, air is coming out of the straw with a higher velocity and it is diffusing with the air surrounding us. Okay, it is getting diffused. Got it? But the reason why it is moving forward, the reason why it is moving forward is so any
so
other
can
doubts over here? You can try another thing. you just can blow a balloon. You can take a balloon, blow it up, and then leave it. So if you leave it, all the air starts coming in the downward direction, and hence the balloon starts moving upward.
So
Right?
same
So
goes
this,
in rockets also, I think.
yeah,
We
the
can
same principle in rockets. Okay.
okay. Sir. So what is the second law of motion?
Okay, as per the second law of motion we had done previously, as per the second law of motion, the force is directly proportional to the rate of change of momentum, right? How fast the momentum changes. That we call as the force which is equal to the rate of change of momentum, and it occurs in the direction of change of momentum. In whatever direction the change of momentum occurs, that is the direction the force occurs.
So can we write force is equals to ma, mass
Yeah,
into
what happened?
acceleration? Can we
Which one?
write force is equals to mass into acceleration?
Yeah, but that's not always correct. We can write, of course, we can write force equals to mass into acceleration, right? But the condition is that your mass should be constant. Okay, mass should not be a variable. If mass is a variable, then we adopt this method only. As per the definition, this is the definition. Not this is the definition. This is not the definition. The definition is this one.
Okay. Sir.
Okay.
Sir, actually in the yesterday class there were few strangers who joined the class with different names. Who were
What happened?
in the yesterday's maths class there were few strangers. Other
Okay.
kids, someone joined in the class.
Okay. So no issues. I will take them out. If anyone joins over here, I'll see to them. Okay.
Yes, sir.
So in my class also in one day someone joined. Okay. So no issues. I take care of it.
So today
Okay. You
also
just
some people joined.
okay. So today also I can see some monkey has joined, right? See, whoever monkey is this is the final warning. Once I go to the technical, then please, whoever is there, your IP address will be traced out. And who is this Afan?
So it's me,
Sir,
Mohammed
actually,
Rayan. Like
Okay.
my ID was changed from them itself. They
Okay.
changed my
So
name. I'm unable to change it.
just change your name. I think you should
No,
be
no,
able
it's
to change it.
unable to. I cannot. They stopped it.
Okay. Okay. Who stopped it?
I don't know. I think the vice have one.
Okay. What's your name?
Mohammed Rayan. I generally join right every day.
yes, sir, he used
Rayan
to
or
join.
Rehan?
Mohammed Rayan.
Rayan. Okay. Is this correct? Rayan? Okay.
Can you
I
repeat,
check it.
sir?
Yeah, it's done. You can just check
Yeah.
your name has been changed. Yeah, monkey, please. Monkey. Now I will. If I inform, then I think for the technicals, your IP address will be traced out.
Sir?
Okay. Just hold on.
Oh,
Okay, hold on for 1 minute. I'm making the technical people find out his IP address and trace him out. Just wait for.
So they left.
Hold on for a minute. I'm just contacting the technical team so that they will find out the IP address. And once they can file out an FIR, then he will know. His parents will come here and there, whoever that person is. Is there any one of you who has shared the class link?
Yes,
No,
sir.
sir.
Is there any one of you who has shared the class link to anyone?
No, sir.
No, sir.
No, sir.
Okay, just one minute. I'm just
No.
contacting the technical team. So once he enters at the same time, the technical team will be able to help him up. Just wait. Okay. I have informed it to the technical team. They will keep an eye on it. Okay, so just we take something for granted that yes, the person should not be uh, if someone is just making fun, so he should not get punished. So once we launch an FIR, so the cyber crimes will find them automatically. Okay. So that's what we don't want to go with.
Yes, sir.
So yesterday the whole class got disturbed. The whole maths class got disturbed due to those stranger.
Okay. I have informed and the technical team will take now if he doesn't obey, then we have to take strict actions against him. Okay. We have strict actions.
Yes.
And for this, I want all of you, not all of you, at least just keep all of your camera on. Okay. So that if anyone stranger enters, so I will be able to notice it quickly. Got it? Okay, so just keep your cameras on. All of you keep your cameras on. Advait, Pranav, Yukta, Harshit, everyone, it's mandatory that your camera should be on.
Okay, sir. 1 second.
So just for the safety during the classes, all the cameras should be on. And just make me some settings also. Okay. Let's continue further. And none of you will make your camera off. Okay, whatever reason being, don't make your camera off. We'll
Okay,
see.
sir.
Okay. So for the third law of motion, we have seen that for every action, there is an equal and opposite reaction. Okay. So we have seen a certain example, like we have seen this toy one. We have seen the toy effect. We have seen the spring balance. We have seen the balloon. So these are various examples of action and reaction forces. What about our walking? Can anyone explain the walking process?
So in the walking, we push the ground backward. Means uh, we keep pressure on the ground and we try to go forward.
Don't say pressure. We push the ground, right? We
Yes.
push the grounds with our feet. So when we push the ground with our feet, then okay. So whenever we push the ground with our feet,
Hello.
yes, sir.
Hello. Am I
Yes, sir.
audible?
Hello. Yes, sir. Yes, sir.
Yes.
So it has been the second class that it was being done.
Hello. Yes, sir. Who was the person?
He was some fake names like dumb names like monkey and anything
Okay.
of that
Just
sort.
you remove. If something is there, you can remove. He may not be able to join, and we will take up with team also, and we will
Okay.
investigate, sir.
Okay, sir. Sure.
You
Because
you
this
can
is the
remove, sir. If anyone is doing some kind of a nonsense, you can remove. He may not be able to
yeah,
join further.
yeah, because children are saying that he was disturbing the maths class also,
Yes, sir.
and this is my second class where he is disturbing.
Right, right, sir. We will investigate that also. And you have that
Okay.
power, you can remove as well. So we are going to just look into that. Who is that person? And also, like Jitendra, video is off. Jitendra, please turn on your videos, beta. If you are unable to turn on the video because of any reason, inform your parent to drop a message to us personally. Okay, sir. Please carry on.
Okay, sir. Thank you, sir. Thank you, sir.
Thank you.
So for the third law of motion, we are looking at various examples. The next one is we are looking for how we walk, our walking process. So while walking on the ground, we push the ground with our feet. So with
Sir,
our feet,
actually, sir, sir, again there are
yes,
two fake IDs.
okay. You just put
Even
a
after
direct
1 year.
message.
Sanpat or some. Sir, you can see three fake IDs.
Okay. Okay.
No, I think it's 2. Okay, now it's 3.
Yes, sir. They left. They are joining and coming over.
Who is this Javed Iqbal?
Sir, he and the
अबे अद्वैत
Niyamit
तू यहाँ
Ravi.
पे this guy Advait Kulkarni, he took my money, sir. He's not returning it since 2 weeks, sir. He took
Okay,
2,000
okay, okay,
rupees.
okay. Just a minute. I'm paying your money. Just give me your number. I will pay your money. I'm just making
Sir,
a
okay.
payment.
Okay.
Okay? Is it
All
okay?
right.
Just share your number. I will pay your money.
6-3.
Please don't disturb my class.
Sir, he's not paying my money since 2 weeks, sir. That bloody rascal. He's not paying my money from 2
Okay,
weeks.
okay. Anyways,
Bastard.
I'm paying your money. Just send me your number. I'm just making a Google Pay on it. Share
All
your
right.
number.
All right, sir.
Okay, share it.
630
630
33
33
108
108
96.
96. Okay. Now you do whatever. I'm going to launch a case against.
Okay, sir.
You think of it. Launch an FIR on. Got it?
Sir left. Sir, in the last class, sir, one guy was telling Jitendra took his money, just like this guy.
Yes, every time.
He told he took 1,000 rupees.
Yes, sir. Now it's like 1,000. Now it's 2,000. Last time 1,000.
Okay, students, no need to worry. I got his contact number also. Whoever was that person,
Sir, it could be even fake number.
it also now. So now we can do, yeah,
Sir, it could be even a fake number.
yeah. So now we have got his contact, so anything can be done. Don't worry.
Okay, sir.
So, so if he just joins again, ever again, I'll just make a complaint accuracy. So while the walking process, whenever we are walking, okay. So whenever we are walking, we just push the ground in the backward direction. We are just pushing the ground in this direction. And when we push the ground, we get an upward reaction like this. So a part of this reaction is used to lift our body in the upward direction, and a part of the reaction force is used to make us move in the forward direction. Right? So that is the reason, that is the way how we start moving. Got it? So here we start moving by this method by first pushing the ground. When we push the ground at an angle, see, if you push the ground vertically, then you will not be able to move forward. If you push the ground vertically, you will get an upward jump. If you push the ground at an angle like this, so then you will be able to get a reaction in the forward direction. Okay, so that is the time you will get a reaction like this. So a part of it will be used to lift up the body, and a part of it will be used to move forward. Got it? Understood everyone the method of this, how we walk?
Yes, sir.
So
Sir, can you
everywhere we have a case of action and reaction. Got it? So at every point, at everywhere, whenever there will be a force, so there will be a force of action and reaction. Just do another example over here. Apart from walking, we do some other examples over here. Suppose I have a
come under this?
hello dog. Hello dog. Hello dog. Okay, just hold on, but I think I need to
That is
update
doing
it.
something and giving, yes.
Yeah. Is there anyone here who knows someone Sujata?
Sir, there is no. Sir, can you repeat the name?
Sujata.
I don't know.
No, sir.
Anyone parents name Sujata?
No, sir. Sir, did you find it in the WhatsApp?
Okay, we'll check for it. Just
Okay.
yes, for the activity of swimming or everywhere, we can apply the third law of motion, right?
Yes, sir.
Okay.
Yes.
Right. Aloli Sujata Nivas.
Sir, is he joined?
No, he hasn't joined.
Okay, is it
I
the
just searched. Yeah, it's Aloli Sujata Srinivas.
Sir, is he asking, means, did he request
Yeah,
to join? Where did you find his name, sir?
I got. Does anyone know
No, sir.
No,
Aloli Sujata
No, sir.
Srinivas? Okay. I will just share with the team also. They will find it out better. Okay, I got his name. Okay, no issues. Just continue our classes. So let's see, we have here a wall, and let's say here we are just wearing a roller skate. We have the roller skates over here, and suppose I'm pulling a rope. I have a rope with me, and I pull this rope. So standing over here, I pull the rope. So what do you think will happen when I pull the rope?
sir, we would move towards the
Yes, I will move towards the
wall.
Wall, we
no.
will move towards the wall.
Okay, if I am pulling the wall like this, I am pulling the wall like this. So on the wall, I am applying a force towards this direction. As a result, I will experience a force in the backward direction. So my body will start automatically moving towards the wall. Okay, so with this,
Sir,
I think we can say that for every action, there will be an equal and opposite reaction. Got it?
Yes, sir.
yes.
Okay. So
Sir, means, if we throw any object like any glass material and if it falls on the ground, the forces are again reacted on the glass object and then it breaks. Is it right?
okay. So what happened over here? Just pardon your question again.
So if throw any glass object on the ground, then the force uh, exerted by the ground, by that force will the glass break. How will the glass break?
Force, no, I again did get you. What did you say?
So if we throw any glass material on the ground, how will it break actually?
How will it breaks? That is, it breaks because of the force of the reaction. See, whenever you are throwing any glass object on the ground, so suppose you throw a glass object on the ground over here. So the glass object, it hits the ground with a certain force. So glass object applies a force on the ground, and the ground applies a force on this. Okay. So because of the force by the ground on the glass object is it breaks up. Okay. It is not able to sustain that amount of force. Got it? So hence it
Yes.
breaks up. So this was about all action and reaction. From the Newton's third law of motion, we come to the conservation of momentum. So the next is our conservation of momentum. We have conservation of momentum. So conservation of momentum, it means that the total momentum remains conserved. In the absence of external force, the total momentum remains conserved. So in the absence of external force, total momentum remains conserved. Okay. So if there is no external force applied, then we have the total momentum acting on a body, it remains conserved. That means the sum of the initial and the final momentum should remain the same. Initial momentum,
So what is initial momentum expressed by
okay.
unit symbol?
Okay, how do we express the momentum?
Sir, P.
How do we express the momentum? Anyone remember the formula of momentum?
Sir, by the alphabet P.
We remember it by?
Change
P.
in velocity by.
No. Momentum is measured as product of mass and velocity. So
Okay, yes,
momentum of
yes.
represented by the symbol P, it is equal to the product of mass and velocity. Okay. So the momentum, it is measured by mass times velocity. Now, if I take the mass will remain the same, but if the velocity is initial, I'll be calling it as initial momentum. And if the velocity is final, so I'll be calling it as the final momentum. Got it? So the formula of momentum remains the same. And you can use this formula of momentum. So we have here our initial momentum. Initial momentum is equal to the final momentum. So the initial momentum will be given by, suppose if there are two objects, so the initial momentum would be given by m1 u1 plus m2 u2, and their final momentum will be given by m2 m1 v1 plus m2 v2. So this is the formula. With this formula, we will be able to solve a number of questions. This is our total initial momentum, and this is our total final momentum. Got it?
Sir, what is initial momentum expressed by which alphabet?
Initial momentum. Then you can write it P with just I in its foot. So this represents initial momentum. Okay, if you want final momentum, so you can write P and symbol F over here.
Okay, sir.
Okay. So any doubts over there?
No, sir.
So change in momentum is written as a triangle P, right?
Okay, see, triangle, whenever you write the symbol triangle, it means change. So if I write delta P means change of momentum. If I write delta V means change of velocity. If I write delta X means change of position.
Sir,
If I
X
write
is
delta
the
T, it means
position.
change of time.
Sir, X means position.
Yeah, X means position.
Okay, sir.
Okay, you can write delta Y also, but generally we represent it by the symbol X. Okay, any other doubts?
Yes, sir. No.
No, sir.
Okay, okay, so by all of you, I think we will be ending up the class a little bit earlier today.
So,
Okay, yes,
sir,
Okay.
actually, I have my science test as 22nd. Can you
Okay.
share the extra questions of motion?
Motion.
Yes, sir.
Okay, I'll be sharing through group. Actually, I don't get time. So today I'll find out time and share it through the group only.
Okay.
Okay.
Okay, sir.
Okay, bye.
Sir, even if you can you send is matter around us pure and matter in our surroundings?
Okay, I'll try and send it to you.
Okay, sir. Thank you, sir. Bye, sir.
Thank you.
सबसे बड़ा
Bye, sir.